Welcome to this lecture. In this short video, we are going to introduce the concept of matrices and give some few properties of matrix operations. So start by defining what a matrix is, and then how to denote a matrix, and how to carry out some operations on matrices. So definition. So you can say a matrix is a rectangular array of objects such as A11, A12, A13, up to A1n, A21, A22, A23, up to A2n. Then A31, A32, A33, up to A3n. Up to AM1, AM2, AM3, up to AMN. So this is how we can define a matrix, a rectangular array of objects given in this form. So notation. Or representation of matrices. So one, a matrix can be represented or denoted by an uppercase letter, such as A, B, C, D, etc. Can say like A equals to 2, 4, 6, 0, or B equals to 1, 2, 3, 0, 4, X, 1, 2, Y. So that's how we can denote a matrix by capital letters. And number two, a matrix can be denoted by a representative element enclosed in square brackets such as, we can say Aij or Bij, or you can say Cij, etc. So that's how we can also represent the matrix. Or also use following the definition we have given. And number three, we say a matrix can be denoted by a rectangular array of numbers. I.e. A11, A12, A13, A1N, A21, A22, A23, A2N, A31, A32, A33, A3N, up to AM1, AM2, AM3, up to AMN. So that's it. So let's give a definition of equal matrices. So definition of equal matrices. So we say two matrices A given by Aij and B given by Bij are equal if and only if they have the same size or same order, and AI equals to Bj for, so this size you can say size m by n for 1 less than or equals to I less than or equals to m, and 1 less than or equals to j less than or equals to n. So remember, order of a matrix or size of a matrix given by the rows of the matrix by the columns of the matrix. So for instance, when you say a matrix A given by 2, 3, 4, 5, and you say a matrix B is given by X, Y, A, B, then A is equal to B if and only if 2 equals to X, 3 equals to Y, 4 equals to A, and 5 equals to B. And you see the order of this matrix, the number of rows 1, 2, so 2 by columns 1, 2. Order of this one is also 2 by 2. And then so maybe just order of a matrix, order of size of a matrix. So this is given by a number of rows of a matrix by the number of columns. So if a matrix has m rows and n columns, then its size or order is m by n, so read as m by n. So let's give a few examples here. Like if I have a matrix, assume I have a matrix A given by 6, 9, 2, 4, 9, 8. And then, so B matrix, and then B, I have 2, 4, 2, 1, 3, 4. Then out of this matrix, so this one, rows are these horizontal lines. So this is 1 and then 2. So I have 2 by columns are these vertical lines. 1, 2, 3. So 2 by 3. And then this one, rows are 1, 2, 3. So 3 columns, 1, 2. So 3 by 2. And then if I have a matrix given by C 1, 2, 4, 6, 2, 3, 4, 5, then the order of the size of this matrix is, so we have 1, 2, so those are 2 rows, and then 1, 2, 3, 4, 4 columns. And then if I have D given by 2, 4, 1, then the rows we have 1, 2, 3, columns we have just have 1. And then if I have E, 1, 3, 5, 6, then row we just have 1, columns I have 1, 2, 3, 4. So 1 by 4 matrix. So 1 by 4 matrix can also be called just a row vector. A matrix which has just one row is also sometimes called row vector. And a matrix which just has one column is also called, sometimes it's called column vector. So last definition for this session, transpose. So the transpose of a matrix A is denoted by A raised power T or A prime, and is obtained, is the matrix obtained by interchanging rows and columns of A. So a matrix obtained by interchanging rows and columns of another matrix A is what is called the transpose of a matrix. So just illustrated by examples. As they call appetizers. Find the transpose of the following matrices. So if I have A given by 2, 4, 5, and 6, B given by 3, 6, 7, 1, 0, 2. Now, the transpose of A, denoted by this, is a matrix. So the first row becomes the first column. So row 1 is 2, 4. So I write 2, 4. Row 2 is 5, 6. So becomes my column 2. So 5 and then 6. So this is my transpose of transpose matrix. Now this is my first row, becomes my first column. My second row becomes my second column. My third row becomes my third column. And if you are to give the order of these matrices, so this A is a 2 by 2 matrix. This is still a 2 by 2 matrix. This one is a 3 by 2 matrix because we have 1, 2, 3 rows and 1, 2 columns. This one is 1, 2, 2 columns, 2 rows, and 1, 2, 3, 3 columns. If I have C, 2, 4, 8, 1, 0, minus 1, 6, 5, and then minus 3, then C transpose will be, so first row becomes my first column, so 2, 4, 8. Second row becomes my second column, 1, 0, minus 1. Third row becomes my third column, 6, 5, minus 3. So order of this one is 3 by 3. This one is 3 by 3. And then if I have D given by 2, 4, 3, 1, 0, 6, 4, 8, let me say minus 4, 5, 1, say minus 1, minus 2, 9. Then the transpose of matrix D is, so this first row becomes my first column. So I have 2, 4, minus 4, minus 1. This one will be 3, 1, 8, minus 2. And this will be 0, 6, 5, and 9. And if you are to give the order or size of this matrix, you see this 1, 2, 3, so 3 rows, 1, 2, 3, 4, 4 columns. And then here we have 1, 2, 3, 4 rows, 1, 2, 3 columns. So this is 3 by 4, and this transpose is 4 by 3. So in general, or let's just say properties of transpose matrices. So say if A and B are matrices with sizes such that the given matrix operation is defined and K is a scalar, then the first property, 1, A transpose is A. That double transpose give the original matrix. And then number B, A plus B transpose is A transpose plus B transpose. So transpose of sum is the same as sum of the transpose. And number 3, C or K A, this scalar K, if you get the transpose of K times A, then the same thing as saying that scalar times the transpose of matrix A. And number 4, if you have A times B is defined, then you get the transpose is the same as B transpose and A transpose. So the next session will also discuss more about matrices operations. Thank you.